Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. And my name is Ravinder. I am an assistant professor with EDC department. And we are discussing the subject called Data Structures 2. And for the past few lectures, we are actually discussing the broad topic that is binary search trees and its types. So we are for the past two lectures, we are discussing the AVL trees, that is your height balanced BSTs. Yesterday we have seen the rotations, that is left rotation and right rotations, to make an unbalanced BST into a legal AVL tree. Today we are going to see a more complex version of these rotations, that is your left right rotation and right left rotation. And after we understood these two types of rotations, we have already gone through we would have already gone through that complete insertion algorithm. So your insertion algorithm is basically inserting a node at a particular place, and the algorithm will decide whether it has to implement one of the four types of rotations to make it, if the tree, your tree becomes, let's say, illegal avial tree, or unbalanced height BST. In that case, your algorithm is going to implement one of these four rotations to make it balanced height avial tree, okay, or your balanced height BST or avial tree basically. Okay, so we have two rotations, that is your left right rotation and your right left rotation. Now the balancing methodology of left right and right left rotations are similar in nature, but they're mere images of one another. Okay. Uh, Now you can say that amongst the rotation, the left and right rotations that we have seen yesterday or in the last lecture are called single rotations, and your left right and right left rotations are called as double rotations. Okay. Now since left right rotation can be accomplished by first uh, implementing the right rotation, that's why I've written here double R rotation. We have already seen that in the yesterday, and after that we'll implement a left rotation. So your left right rotation is actually a combination of first performing a right rotation, then a left operation rotation. And similarly, your right left rotation will be your left rotation, accompanying with right rotation in the same order as been shown here. So we're going to see how we're going to deal with this. Let me uh, head you to the notes directly. So first we're going to see your right left rotation. Now right left rotations are to be performed if a new node is inserted into the left of right subtree of critical node A. Please be focused on the line, the left of right subtree of critical node A. If this is your let's say tree, so you can see the left of right node of critical node A. Now this is your critical node, that is A, that is A. Now the right node of this is B, and we have inserted to the left of B, that is down here. So this is what the definition is trying to say. Now let us consider that node B is the root of right subtree of the critical node, and node C is the root of the subtree in which the new node is inserted. So we have already seen that we have inserted a node here. Before that, this is a height balance tree. This is an AVL tree. But after the insertion of the node, as you can calculate, you can pause the video and you can calculate the height. So you will see that this particular node A, the tree is going to be unbalanced at this particular node A. Okay. How? The height of this particular portion is h minus 1. So you can add 1, that is h, and then h plus 1 and then h plus 2, while this particular node here at the same level as B still has a height of h. So the difference or the balance factor is going to be plus 2 or minus 2 as you wish to calculate, or simply put 2. Or 2 is out of our constraint range or a permissible range to be a height balance tree. So that is why there has been an imbalance created with respect to node A. That is why we have called it a critical node A. Okay, so in this case you can see that that particular node A is happens to be your root node, but this could be any other node. Okay, all you have to do is you have to, again, like I have said in the last lecture, that you have to find out the nearest node when we are going to proceed from the newly inserted node towards the root node. So we have to find that nearest node which is actually imbalanced, or on which the balance factor is out of its range. Okay, so let's start with the operation. So the first operation will be after insertion of node. You can see that balance factor at A is -2. So after the insertion, the first operation that is going to be, in case of right left operation, is going to be your left operation. That is going to be your left operation. Okay. So we'll go through an example first, and think, with the help of example, it's going to be much easier to understand what we are trying to say. So this is an example. Now we have to insert a node 92 into this AVL tree. As you can see, we can only insert 92 at to the left of 95, because 92 is greater than 90, and then again it is less than 105, and then again it is less than 95. So it's going to find its place here. So this is an exact event for which your left-right rotation is applicable. Sorry, your right-left rotation is applicable. Okay, now here it has been shown here. We're going to insert 92 here. Now the first case is, we're going to have a rotation that is your left rotation. So this particular 95 is going to take the place of 105. So 95 is going to be there up, and this 92 will switch loyalties now. Okay, next is what is going to be is your right rotation. When your 95 is up there and your 105 and 110 are down there, then you will going to experience a anti-clockwise rotation. If you are not familiar with this clockwise and anti-clockwise, that is right and left rotation, please refer to the last lecture, because if you don't understand what is your left and right rotation, you people are not going to understand what I am trying to say here. You people are not going to visualize what I am trying to say here. Okay, so when this first rotation is your left rotation, please follow the cursor. Your 105 and 110 is going to come down, the 95 is going to go up. Okay, then again there's going to be a right rotation. Right rotation is going to happen with respect to node 90. Okay, so this 90 will come down, your 105 will go up as a root node. Now at this your 95 is going to go up, as we have, I think we have missed one step here in between, but as you can visualize, 105 110 will go down, 95 will go up here at this place, 92 will be still connected to it, and then the after your right rotation, your 95 will be up there, and in that case your 92 will switch loyalties from your 95 to 90, because if we have left it right at like this, that is to the left of 95, but it cannot be to the left, it is going to be right at this place. It is not allowed according to the rules of BST, because 92 is a value smaller than 95, so it cannot be in the right hand side. So now it's going to switch loyalties from 95 to 90. Okay, so this is how your right-left rotation has been performed. First, there is a left rotation in this particular subtree. Please follow the cursor in this particular subtree. So your 100, 510 are going to come down, 95 is going to come up, and then you will have a right rotation along this portion here. Please follow the cursor in this portion here. So your 95 will go up and 92 will switch loyalty from 95 to 90, and this is how it is going to be resulted. Now this is your legal AVL tree. Okay, so this is how you are going to perform your right-left rotation. Next, we are going to see a left-right rotation. Now, left-right rotation is again a combination of two types of rotations. That is your right-right rotation first, and then your left-left rotation first. Okay. Now, the rules are basically same. Let me write it out for you. So your left-right rotation is to be performed if the new node is inserted into the right of the left subtree of node A. Okay, so this is basically inversion of what we have seen. Now in left-right rotation, the node C, which has been there, becomes the root node of the tree. Okay, and while node B and A becomes its left and right child. So this is your right, this is your left, and this is your middle. And middle is always going to be your root node. So you have to identify which node is your left, which is root node is your right, and which node is going to be your middle. If you can identify these three nodes, you can easily identify or restructure your node, your tree, your unbalanced tree after the insertion of a new node into an AVL tree. Okay, so let me head back to this particular. In this particular example, we're going to see what is happening actually. Okay, I think this was the example that we have already seen. So what we're going to do is, let me change this to the example that we are discussing now. Yeah, I'll copy this. Okay, let's try to figure out what is actually happening here. So first, in this particular case, because this is it is the new node has actually been inserted to the right of the left child of the critical node. Now critical node is 78, and it has been inserted to the right child and towards the left of that particular child, and as you can see, towards the left of this, okay, and this is to the left and towards the right of the child. Okay. So I think you have got the point what I'm trying to say. Don't get confused with my language. I think I've myself got confused. So this new node has changed the things substantially, because now this at this particular node 78, your balance factor is +2 or 2 basically. Okay, now you can say that this particular tree is not height balanced, it is unbalanced with respect to your node 78. The first, as you can see, the insertion is to the left hand portion of the tree. So what we are going to do is we're going to apply your rotation, that is your right left rotation. So first we are going to encounter, we are at the left right rotation now. So first we are going to see a right rotation and then a left right rotation. Okay, we have already seen the example of right left rotation. Now we are seeing the example of left right rotation, and in the left right rotation, first we are going to perform a right rotation. So there's going to be and rotation in the anti-clockwise direction like this, okay. What I'll do is I'll do this, and again I will draw this, because yeah, like this. So this is how your rotation is going to be. So 75 will come up, 67 and 50 will go down, and 70 is still attached to 75 but towards the left. At this point it is towards the left, but at the time it's going to be it's going to take place, or you can say it's going to switch its loyalty from 75 to 67. Okay, as you can see here in this particular case. So what is going to be there is the 75 will be there, 65 and 50 will go down, okay, and 70 is attached to 67. Now there will be a second rotation, and at that point, when the first rotation has already been done, now this rotation is going to be in this direction, like this. This rotation is going to be in this direction, and in that particular case, your 75 will go up, and 78 and 90 will go down, like this. You have seen it. Now imagine this, that Imagine this particular tree as 78 up, 75, 67, 50, and 70 as in this particular attachment, and 90 to the right hand side. So all we have done here is we have just rotated rotation. We have done a single left, right rotation. Okay, I think you have got the point what we're trying to do here. So first 75 will go up, 70 will change loyalties from 75 to 67, as you can see here in this particular section. The 70 formerly attached with 75 is now been attached with 67. And after that, there will be a single rotation, that is your right rotation, in which your 75 will actually go up and your 78 and 90 will go down. And in that particular point, your tree is going to be your height balance tree, and that particular tree will be can be called as a legal aviary. It is hard to imagine like this. All you have to do is just take your pen and pencil or on your copy and try to do those rotations in steps. Do those rotations in steps. First, focus on this particular subtree here and perform a single left, right rotation. Okay, perform a single right rotation. Okay, and then and switch the loyalties as we have discussed in the last chapter, last lecture, and then you'll try to rotate at the critical node. You'll try to rotate and a critical node in the clockwise direction, and then you will exactly see what I'm trying to do. Okay, so I'm going to end this lecture now. I think we have understood what is your left, right, and right, left rotation. If I got confused between the names, that is right, and left, please pardon me. You can only please be focused on the clockwise or anti-clockwise if you get confused in left or right rotations. Okay, that would also help. So thank you.